Ideally today we can get this done. Notes, 10 minutes maybe. Assignment done. Maybe even graded. I don't know. We'll see where the day takes us. But today is 8/27, and we're going to be doing two different things with complex numbers, okay? So again, we're still working with complex numbers just quite explicitly, and we will be accomplishing two tasks today. Task number one, and I'm going to do these in the right order, is we want to be able to find the distance between two complex numbers. And then task number two is we want to be able to find the midpoint. I don't give this lesson a lot of respect only because I know it's not, and you may not buy it at first, but it's not the first time you've seen this. So um, I I do have to give it to you a little bit in the fancy context first. And by the way, on your assignment number 3 that you're about to get, I do have these formulas up at the top for you because they can be a bit annoying to memorize, but um, see if you have any recollection of this. And I say I'm always a little reticent to give you the fancy one because it's almost like overkill. But generally, we're going to refer to complex numbers by using the letter Z. And so a complex number might have the name Z1. So that just simply refers to the fact that the first complex number is his name is Z1. One, as you know, in this case is what we call a subscript. It has no mathematical significance. We use subscripts in math and anything else when we just want to label things. Like you've seen it in the slope formula. You guys remember slope? How the slope is y2 minus y1. Like that's just labeled. That's like saying the second y minus the first y. This is the same thing. So if we have a complex number whose name is a plus bi, and then we have another complex number, what do you think we call the second complex number? Why not? Let's call him z2. And his name cannot be a plus bi because then that would imply that z1 and z2 are the same complex number. So we don't get too creative with this. I would just call it like c plus di. So I'm going to put this up. People that are mathematically like just strong and confident, you're like, bring it, like you got math armor on, this won't bother you at all. But if you want to find the distance between those two complex numbers, the formula is a big square root sign. And we're going to do quantity C minus A squared plus the quantity of D minus B squared. And I'll say again, really depends like maybe at what point you took geometry, but this I believe is still taught in that one class. We just reteach it a little bit because we want to make sure we're clear that you can apply it again in the context of complex numbers. So is that ringing any bells? You've seen this formula before, right? Your teacher, whether it was last year or the year before, didn't necessarily phrase it this way because you weren't talking specifically about complex numbers. So before we get going and show you how easy this actually is, what you're used to is instead of me talking about Z1, a complex number, Mr. Manlove or Miss Crump, whoever that was, they would have given you just a point. And so for a good example, let's say they said, okay, we have a point in the complex plane, and let's call it like 3, 4. What I want, if you didn't already figure this out, here you go. Newsflash. The 0.34 is directly corresponds to what complex number? 3 plus 4i. So whether I come at you in the context of calling it the complex number 3 plus 4i, or another teacher comes at it and says it's the 0.34, you're still going to go right 3 and up 4 to get there, correct? Okay, so regardless of whether we're talking about the complex plane or the Cartesian plane, a point is still a point. And a distance between 2 points is still a distance between 2 points and can be obtained with this formula, again, regardless of context. Clear? Okay. And again, the point Z2, the complex number Z2, could easily be considered as a point. And a point in this case could be something like -1, 6. And what complex number would that correspond to? -1 plus 6i. So as we proceed here for the next couple of minutes to refresh our memories on the distance formula, bear in mind that you've seen this before, just different context. Okay, so what the distance formula says, and I'm going to illustrate this one for you. You're welcome to do it in your notes. You're also welcome not to. I do stuff like this just because I want you to get eyes. I want you to get eyes and always sort of have a behind the scenes peek. at what's happening when your math teacher talks about weird stuff. So how would I plot the point 3, 4 or graph the complex number 3 plus 4i? Z1. Correct. Right 3 up 4. So if I'm going to graph Z1, I'm going to go right 3 up 4 and put a dot like right here. Good. And if I'm going to plot the complex number or the point, either -1 plus 6i or the point -1, 6, how am I going to get there? I'm going to go left 1 up 6. And so to get to Z2, I'm going to go left 1 and I'm going to go up 6. So something probably about like this. Good. Listen, this is a hot topic in math, and it just happens. And it's one of those things that is so real worldly applicable that, I mean, it's good that it keeps coming up again and again. It's easy to find the distance between 2 points if they're across from each other, right? If they happen to be the same height, then even a monkey could find the distance by just literally counting the spaces, right? Or if they're vertically above and below each other, same conversation. It's easy. But when points are diagonally associated with each other, what's the trick we use? What's that thing called again?
Plus B squared.
It's just a squared plus b squared equals c squared. So that formula that you see up there on the board, that big long white formula that you'll see on your homework assignment, is really just a snapshot of what it looks like when you solve out the Pythagorean theorem. I hope we agree. So if I said to you, find the distance between the green point and the yellow point, let me zoom in on this a little bit, you would, bless you, I think you would very obviously want to know the length of this red line. And I hope that you would also want to know the length of this purple line. And can we agree that those are both obtainable by just doing some basic math? Okay. So I'm just trying to bring this all. I care about you, and I don't want to just say, here's a formula, use it. Like, understand when you look at the formula, it may look like a lot, but at the end of the day, in my picture, I have to zoom back out. In my picture, can you tell me which colored line goes with C minus A? The purple. Because the purple one is saying to take your real coordinate minus your real, aka your x coordinate minus your x, right? I'm sorry, I have to interrupt this real quick. Well, everyone's here, so that's the good news. Remind me when I answer the phone, I got to do that. My bad. Good. I don't think you probably need another one of those, guys. It's something you already know, and you'll see the formula, but you don't have to think it's a big thing. It's what you already know. Good. And then the same can be with the midpoint. And I'll just use the same problem because I already have it drawn up here on the board. And so I'm going to erase a bunch of stuff here. And the midpoint, again, is one. I love classes of this level because I can reason with you and I don't have to go into a lot of, explanation-y kind of stuff. So this will be really easy for you to understand. The midpoint formula looks, as with the distance formula, it looks more complex than it actually is. So we're going to use the same two complex numbers. So we're going to have Z1 and Z2, and they're still going to be called A plus BI and C plus DI. Deal?
Okay.
The midpoint of two complex numbers, capital M, is going to be the complex number that we will call A plus C over 2 plus B plus D over 2i. When Mr. Manlove or Miss Crump taught you the midpoint formula, they didn't use that terminology. They used a different terminology. They said something like x1 plus x2 over 2, comma, y1 plus y2 over 2, and they put it in parentheses like this. Does that ring any bells? Okay. Again, different context, same mechanics. And since you're in an advanced class, you should be able to answer this question with the greatest of ease. And I don't want you leaving high school if you can't answer this question with the greatest of ease. What does it mean to add two things together and divide by 2? Nope.
Average.
You're finding something called an average. And so what this is going to boil down to is you're going to find the average of the real coordinates. You're going to find the average of the imaginary coordinates and call it a day. Again, a formula, a simple classic case of a formula that looks really difficult but is not. So let us consider our A and our C values. Since our complex numbers, let me put these back up here. So you remember that Z1 was, what was it? 3 plus 4i.
D2 is -1 plus 6i.
Thank you. I shouldn't have probably erased those. So there's our complex numbers. And so if I want to find the average first, it's really easy. Keep those eyes open back there, right? It's really easy to get lost if we sleep through stuff like this. If I want to find the average of two things, there's two kinds of people in this room. Some of you will just eyeball it, and some of you will take the math very seriously. What are my real coordinates for my complex numbers?
3 and -1.
They are 3 and -1. Can anyone just right now tell me what's halfway between 3 and -1? 1. There's always people that just get that. And then there's people that go, how did you get that? And if you're in that second group, I don't know what to tell you. Like you could look at a number line and say, okay, three's over here, -1's over here. If each guy walks the same amount and they meet for lunch, you can have those kinds of conversations. But if none of that clicks with you, then you just take the formula really, really seriously. And you go 3 plus -1, which is 2, and you divide it by 2, and you get 1. It'll work 100% of the time, right? What is the average of my imaginary coordinates?
5.
It is halfway between 4 and 6 is 5. So what is the midpoint of the two complex numbers?
1.
1 plus 5i. All right, let me give you another one and let's find the distance in the midpoint and then I'll shut up. Good. So let's do a first complex number can be, I'm not going to call them z's and all that stuff. Let's just call the first one like -2 plus 5i. And then let's call the other one 3 minus 7i. And I'd like you guys to find the distance between them, and I'd like you also to find the midpoint. And then I will release you, so to speak, to just work on your assignment. If you do this problem, it'll help you stay awake. Pro tip, life hack.
Great tip.
When I bother you guys for sleeping, it's not because I have anything against sleeping. I love sleeping way more than you could possibly imagine. It's just that every time you fall asleep in class, you're unfairly making more work for me down the line because then I have to teach something again that you chose not to hear. So always bear that in mind that when I pick on you, it'll be for that reason alone. You with me there, Chase? It can be easy if you go way too heavy on the formulas to get them like mixed up. Just remember common sense. What am I thinking when I think distance formula? What's a simple way for me to do the distance formula? What do I think? Say again? I'm thinking of the Pythagorean theorem, right? I'm thinking of distance between these squared, distance between these squared, right? And I didn't really think this one through because I think you're going to get a fairly obnoxious distance, just FYI.
Completely.
Oh, wait, did it come out nice?
Yeah.
Wow. Didn't even mean for that to happen. It's like magic. I should go buy a lottery ticket. Good. So I'm hearing some people say that it worked, and that's a great sign. You should have figured out that the distance between these 2 points, oddly enough, is exactly 13. 13 units. Everybody have success with that? Okay, good. So again, what it came down to in our minds is we just said, okay, how far apart is -2 from 3? That's 5, and 5 squared is 25. And then how far apart is 5 from -7? Well, that's 12. And then 12 squared is 144. I mean, you add them up, 169 squared or 169, done. What would be the midpoint of these two complex numbers?
1/2 and I.
So 1/2 is the real coordinate. And then what's the imaginary?
Plus 1. Oh,
Minus I. So you can be as mathy as like literal about the formula as you want, but the bottom line at the end of the day is if you took the number -2 and 3 and met in the middle, you would meet at the point 0.5 or 1/2, right? And then as far as 5 and -7 are concerned, if Bryce was standing at 5 and Jackson was standing at -7, and they each walked equally fast towards each other, they would rendezvous at the number -1. So that's where the -I comes from. Do you have any questions on this? All right, I'm going to hand out assignment 3, and you're going to get crack-a-lackin'. If you're interested, okay? So when I'm finding distance, I just simply find how far away the purples are. 2 is 3 away from 5, and 3 squared is 9. And then I figure out how far apart is 3 from -4. The answer is 7. 7 squared is 49. All right, so you're just finding a distance. Don't make a math problem out of it. Just use your brain. 9 plus 49 is 58. So the answer is the square root of 58. And I get the question, is it dead? Is it dead? Is it dead? And the answer is, yeah, of course it's dead. The only way you could break it down would be 29 times 2, and that's no good. So as far as the midpoint is concerned, what we want to think about here is just what's halfway between the two things. So there's a couple schools of thought on this. If you're someone who really likes numbers and you really like thinking about them, you could look at a 2 and a 5 and very simply say, what is halfway between 2 and 5? And the answer is quite simply 3.5. So if I do it this way, if I think in terms of literally with my brain, what's halfway between 2 and 5, then I'm settled on 3.5 or 3.5. If you're going to really embrace the formula, then you're going to take red plus red, which is 7, and then you're going to divide it by 2, and you're going to call it 7 halves, like that. Understand it's the same thing, right? One is just using a formula. One is more trying to use your thought
And
process.
you only use the front numbers? Oh, I guess both of them work.
And then the back, I'm going to do the exact same thing. I'm going to say what's halfway between 3 and -4. So again, if I think in terms of a number line, then I know that the answer is that it's -1/2, right? But if you're someone who's like, screw it, that's way too much thinking, then you're going to do 3 plus -4, and you're going to divide it by 2, which is -1 divided by 2, which is same. Got it? It's a very repetitive process. I would encourage you to not do everything by just plugging numbers into a formula. Stop and think about what you're doing, because you don't really need formulas for any of this, just FYI. Anyone else need some more assistance? Sure. So in problem 3, we have -2 minus 1i. And then the other complex number is 4 plus 2i. So I'm just going to ask you some basic questions. How far apart is purple from purple? 6 squared is 36. Okay. How far apart is red from red?
Okay, so it's
-1, of course, right? How far apart is -1 from 2? 3 squared is 9. 36 plus 9 is 45. So the distance between the 2 points is the square root of 45.
2 squared.
You okay?
Square root of 52.
And then, of course, we would break that down, right? Because 9 and 5.
2 away from finding, and then you just do 2 plus.
Is it because there wasn't a number right there?
4 and 4 and 30.
No,
Square.
They go to 14.
Right there.
For some reason.
So it's 2.
Where did you see any?
Yeah, I mean, it's seriously no different than saying this is the point -2, -1, and this is the point 4, 2. Forget the i's, just look at the numbers. How far apart is -2 from 4? 6, right? How far apart is -1 from 2? 3. Like, don't get all bogged down with all the other stuff. You okay? So what are you gonna get when you break that down?
Cold turkey.
Nice job.
Jackson.
And are you good on the midpoint, or you want me to do that too?
That's
Okay.
okay. So 4 and 4, which is 16 and 16.
Might work on
What is
these
16?
kids have it.
What is